Hello everyone, welcome back to the course Digital Signal Processing. In today's class, we are going to discuss about some of the properties of the Twiddle function we are going to use in solve the computation of endpoint DFT of the given signal. And we know that the endpoint computation of the given signal is given by the expression that is x of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi by n into kn, where k is taking the value 0 to less than or equal to n minus 1, where n is the fundamental period of the given signal, that is x of n what we are going to consider. Okay. So in order to simplify this expression, we are going to use one more important factor, and that factor we call it as a w of n, or it is also called as a omega of n. So which is nothing but e power minus j 2 pi by n, which is nothing but minus j 2 pi by 1, and this factor we call it as a Twiddle factor. This factor we call it as a Twiddle factor. This factor we call it as a Twiddle factor. So if I substitute this expression in this above expression, so what you'll be getting is you'll be getting x of k is equal to, you'll be getting x of k is equal to summation n is equal to 0 to n minus 1, n is equal to 0 to n minus 1 x of n into omega into the power of k into n, you will be getting x of n into the power of omega into k into n, you will be getting. So say similarly, where this k is taking the value the same range, that it is taking the value k is equal to 0 to n minus 1, it is taking the value. So let us try to find out, so what are some of the properties which are associated with this Twiddle factors. So the first property which is associated with Twiddle factors, we call it as a periodicity property. We call it as a periodicity property, periodicity property. So what it says that we know that the periodicity property will holds good for the fundamental period which is equal to n. So that is nothing but omega n to the power of a plus n, where n is a fundamental period of the given signal, means then it can be written as omega n to the power of a. It can be written as omega n to the power of a. So let us try to solve this expression. So why we are getting this omega n to the power of a plus n, which is nothing but omega a only. Okay, and we know that omega n to the power of 1. So we know that omega 1 to the power of n, what is that? It is nothing but e power minus j 2 pi by n. Now what we need is we need a power a plus n in the bracket we need. So what, let us try to multiply whole the thing is with the a plus n. So if I multiply the whole term at the right hand side also, you'll be getting a plus n. Now we know that e power a plus b can be written as e power a plus a power b. So if I simplify this, what you'll be getting is, so e power minus j 2 pi by n into a plus into multiplied by e power minus j, you'll be getting 2 pi by n into n, you'll be getting. Now you can see here the denominator also you have a n and the numerator also you have n. So both these two will be terms will cancel out. So if these two terms will cancel it out, means then you'll be getting e power minus j 2 pi by n into a multiplied by e power minus j 2 pi, you'll be getting. Now if I simplify this expression, so what you'll be getting is, so you'll be getting cos 2 pi minus j sin 2 pi, you'll be getting minus j sin 2 pi, you'll be getting. And we know that cos 2 pi is always the answer is equal to 1, and minus j, what is the answer? Sin 2 pi, it is always is equal to 0. So therefore the answer what you'll be getting is, you'll be getting the answer is equal to 1. So now if I simplify that expression over here, means, so what you'll be getting is, which is nothing but e power, the first term e power minus j 2 pi by n into a into multiply by 1 you got. So now what is this? It is nothing but, it is a Twiddle factor, that is nothing but omega n to the power of a into 1. So therefore omega n to the power of a plus n, omega n to the power of a plus n can be written as omega a. So this we call it as a periodicity property of the Twiddle factor. So it is a fundamental period with a period which is value is equal to n. Okay, so this we call it as a periodicity. Now let us try to go for one more important properties of the Twiddle factors, and that we call it as a symmetric property. That we call it as a symmetric property of the periodicity, symmetric property of the Twiddle factor, Twiddle Twiddle factor. Okay, so what is this says that it is nothing but the omega n to the power of a plus n by 2. Omega n to the power of a plus n by 2 is nothing but minus omega n to the power of a minus omega n to the power of a you will be getting minus omega n to the power of a you will be getting. So now let us try to find out how we are getting, that is LHS is equal to RHS. We need to prove it. Okay, so let us take the left hand side of the expression. So what you have, omega n to the power of a plus n by 2, omega n to the power of a plus n by 2. So how we can represent it is nothing but e power minus j 2 pi by n whole multiply by, what is this, it is nothing but a plus n by 2, a plus n by 2 you need to do it. So if you do that, what you'll be getting, again e power a into b, a plus b is nothing but e power a into e power b. I can do that. So that is nothing but minus j 2 pi by n into a into e power minus j 2 pi by n into n by 2 will be getting. Now you can see here the numerator also you have a n and the denominator also you have a n. So and this here also you have a 2 and here also you have a 2. So what you'll be getting is e power minus j pi is there, and one more important term what you have is e power minus j 2 pi by n into a is there. So now let us try to simplify this expression. So what you'll be getting is, it is nothing but you'll be getting cos pi, that is you'll be getting cos pi minus j sin pi, you'll be getting cos pi minus j pi will be getting. So cos pi, you know that the value is equal to minus 1 minus j. So what is sin pi? The sin pi is value is 0. So therefore when you substitute this, you'll be getting a minus 1. So this entire term, what it has, it is treated as a minus 1. So if you do that, means, so what you'll be getting is minus e power minus j 2 pi by n into a you'll be getting. Now what is this? E power j 2 pi by minus 1. So it is nothing but omega n to the power of a, and you have a minus. Therefore LHS what you had, it is nothing but omega n to the power of a plus n by 2, which is nothing but minus omega n to the power of a. So this we call it as a symmetric properties of the Twiddle factor. Okay, thank you.